So, last time we have started a new lesson like metallurgy, and in that we learned that metals are extracted from their ores. Ores are minerals from where a particular metal can be extracted commercially with low effort and minimum cost. So we learned about some of the ores also, some of the main ores of aluminium, iron and zinc. Today we'll be learning extraction, how to extract metals, and before that we'll be learning what is metallurgy. Metallurgy, the process used for extraction of metals in their pure form from their ores is referred to as metallurgy. So what is metallurgy? The process used for extraction of metals from their ores in their pure form is known as metallurgy. And metallurgy deals with the production and purification of metals and manufacture of alloys. So this metallurgy is a vast subject actually. Even metallurgy of copper only can be a used book. But in short, here the knowledge has been given. So metallurgy deals with the production and purification of metals and manufacture of alloys. So there are steps involved in metallurgy. Extraction of metals. Extraction of metal. First of all, we have to locate where the particular metal is in abundance. We'll locate the site. Then we'll go for what kind of ores it has, and all the studies regarding ores. What is the composition of particular metals in that and all. Then after that we follow these 5 steps. Extraction of metal from its ore consists of the following steps. Number 1 is crossing and grinding of the ore. So the ore, first of all, whatever ore we get from the crust of the earth, we cross it. It may be in the form of used powders, used rock. So first of all, it has to be converted into powder, fine powder. Okay, pebbles, then fine powder. So that what is crossing and grinding? Crossing and grinding means to make the powder form of the ore. Then concentration or dressing or beneficiation of the ore. The second after crossing and grinding, what we do? After crossing and grinding, what we do? Concentration of the ore or dressing of ore. Concentration of the ore means if we can remove some of the impurities physically. Okay, after crossing and grinding, it will be spread, and then if we can remove, separate the impurities physically, okay, then that will be concentration of ore. For example, after bringing a bag of rice, what we do? We just put it onto the floor, spread it, and try to pick the unwanted substances from there. That is concentration of rice. Similarly, if we remove impurities from ore, which can be done physically, that comes under concentration of ore. Then number 3 is conversion of concentrated ore to oxide. So number 3, what is our intention? Our intention is to get pure metal. So first of all, what we do? Crossing and grinding. Second, what we do? Concentration of ore. Then after concentration is done, we convert that ore into oxide, because it will be easy for us to get metal from oxide rather than from any other compound. So we convert the ore into their oxide form, and this can be done in 2 ways, that is roasting and calcination. Then after it is converted to oxide, then number 4, we reduce the oxide to metal. Number 4, what we do? Reduce the oxide to metal. And number 5, refining or purification of metals. After the metal we get by a reduction of oxide, this metal also has some of the impurities, and these impurities can be separated in the process called refining. This is the way how extraction of metals is done. We will see this in detail. So this is the flow chart for the extraction of metal. First of all, get the ore, and then we do crossing and grinding. Second step. Third, concentration of ore. Fourth, excuse me. Fourth is roasting and calcination. That is of metal, converting the ore into metal oxides. Then reduction, reducing metal oxides to metal. Then refining, and then we get pure metal. So from ore to pure metal, there are how many steps? 1, 2, 3, 4, 5. There are 5 steps from ore to pure metal, and these 5 steps we will do in detail. So crossing and grinding. So first step, after knowing that there is the ore, after getting the ore, after extracting the ore from earth's crust, the first step we will do is crossing and grinding. And in this process, what we do, maybe the ore that we have extracted from the earth's crust is in the form of used rock. So this has to be crossed. Crossing means converting into fine powder. Grinding, crossing and grinding are the same thing. So crossing, maybe it can convert it into small pebbles, and grinding again we convert it into fine powder. So this fine rock to powder form, rock of ore to powder form of ore is done in the process called crossing and grinding. And this process of converting rocks to powder ore is also called pulverization. So ores are crossed into fine powder in big jaw crusher. There is a big jaw crusher which crosses and ball mills. This process is called pulverization. This is done. So why do we do this process for crossing and grinding? This is done to increase the surface area for speedy reactions, so that there is a speedy reaction, so that there is a speedy work. We increase the surface area. Of the ore, and this is called crossing and grinding. Then the second step is concentration or dressing of ores. So in this, just I said what we do after crossing or grinding, the surface area will be increased, it will be spread. Then some of the impurities can be physically removed, and since the impurities are removed, so whatever left is concentrated ore. What is left? Concentrated ore. So let's see here. The process of removing gangue I said impurities. This can be sand, this can be clay, this can be rocks, this can be any impurities associated with the ore. Are all gangue. So the process of removing gangue, the rocky impurities like silicon dioxide. So one of the impurities is silicon dioxide. Don't think that okay, silicon dioxide is only removed during this concentration or dressing of ores. No, this is one of the examples of impurity, that is silicon dioxide. So all the gangue, the rocky impurities present in ore, okay, can be separated in this state. So it's called concentration of an ore or ore dressing, and the purified ore is called concentrated. After the removal of impurities, after the removal of gangue or matrix, whatever is left, that is called concentrated ore. And commonly used methods for this concentration or dressing of ores are by hand picking. So physically also we can remove, say for example, some of the husk and all can be removed by our hand also. Pebbles from pulses also be removed by using hand. Similarly, some of the visible impurities from the ores can be removed by hand picking. And number 2 is gravity separation or hydraulic washing. So we'll see now gravity separation. So this concentration or dressing of ores can be done in 4 ways. Okay. So concentration of ore can be done in the following ways. What are the ways? Number 1 is gravity separation. This is gravity separation, and this gravity separation is also called hydraulic washing. And then number B is magnetic separation. Then C, from flotation, and then D is chemical method or leaching. So let's see stepwise this of in detail gravity separation, how we do, then magnetic separation, then flotation, then chemical method or leaching. So first of all is hydraulic washing or gravity separation. So gravity separation is also called hydraulic washing. So in this, what we do, what is the principle? How do this method works? Let's see. So the difference in the densities of the ore and the gangue is the main criteria. So how do we separate ore from impurities? How do we separate ore from impurities using hydraulic washing or gravity separation? There must be the difference in the densities. There must be the difference in the densities of impurities and gangue. Method, how do we do? The ore is poured over a sloping, vibrating, corrugated. Corrugated means not even, uneven. See, you can see this uneven, sloping table, and this is sloping, vibrating, and this table will be vibrating like this. It will be vibrating like this, so that the heavier particles comes down, so that the lighter particles comes down, and heavier particles will be settled in these grooves. So table with grooves, and a jet of water is allowed to flow over it. The denser ore particles settle down in the grooves, and lighter gangue particles are washed down by water. So you can see here, this is from this speed water at very high speed is coming, and here is the mixture. Here is the ore to be concentrated, crossed or grinded. Powdered ore is kept here. Powdered ore means after one crossing and grinding of ore is done, that crossed or grinded ore is kept here. Then this is washed by water with very high speed, and then the heavier particles with high density settles at these groups, and these groups. So what are the things present in these groups? These are the heavier particles. So generally ores are heavier than gangue. Ores are heavier than gangue, and these ores are settled in these groups, and the lighter gangue particles will be washed away, and here it is collected. So you can see this is water along with gangue. So impurities is separated. Gangue is separated from the ore. Gangue is separated from the ore by using this vibrating corrugated table. Okay? So gravity separation using water and vibrating corrugated table. So what are the things we have used here? Vibrating corrugated table. Corrugated means uneven table, sloping table, and then with the help of water. We wash away all the impurities present in the ore, and the impurities is kept here, and ores are present in these groups. So which of the oxides can be concentrated by using this method called hydraulic washing or gravity separation? Oxide ores of iron and tin are concentrated by this method. So all metal ores cannot be separated, cannot be concentrated by using hydraulic washing or gravity separation. Which of the ores can be concentrated by using this process? Only ores of iron and tin. Only ores of iron and tin can be separated by using this method, because iron is also heavier and tin is also heavier than the impurities. So one of the conditions for the use of this method is one of the ore has to be heavier than impurities. Ore has to be heavier than impurities. Now we'll see another way of separating, of concentrating ore, and that is magnetic separation. So see this magnetic separation. So on which principle does this separating method works? Principle magnetic properties of the ores. So here ores and impurities, one has to be magnetic and one has to be non-magnetic. So here impurities must be magnetic. Impurities must be, for using this method, impurities must be magnetic and ore must be non-magnetic. Both cannot be magnetic and both cannot be non-magnetic. If both is magnetic, we cannot use this process. If both is non-magnetic, we cannot use this process. So in order to use this process of concentration of ore, one has to be magnetic and one has to be non-magnetic. So let's see how this method works. The crossed ore is placed over a conveyor belt which rotates around two metal wheels. So here the crushed or grinded powdered form of ore is kept here, okay, is poured here, and then this is the conveyor belt. This is the conveyor belt. It is fitted with electricity. This is also called electromagnetic separation. This is also called electromagnetic separation. So these wheels rotates. These wheels rotates using electricity. So this powdered ore is moving on the conveyor belt, at a very high speed. And then what happens is, since this is magnetic wheel and this is non-magnetic wheel, this is magnetic wheel and this is non-magnetic wheel. So magnetic impurities get attracted. This is magnetic impurities. Magnetic impurities get attracted and it is collected here. Non-magnetic ores are thrown away. Non-magnetic ores are thrown away. Magnetic impurities are attracted. As a result, these thrown away ores are collected here. That is non-magnetic ore. And then this attracted magnetic impurities are collected here. So this way ore can be concentrated. And what kind of ore can be concentrated by this method? This method is used to separate tin stone. This method is used to separate tin stone because tin is non-magnetic and impurity must be magnetic. So it contains magnetic oxide of iron, that is Fe3O4 as impurity. So what is the impurity? Here impurity must be magnetic. Either it has to be the compound of iron, either it has to be the compound of cobalt, either it has to be the compound of nickel. Otherwise, this process cannot be used. So impurity has to be magnetic and ore has to be non-magnetic. Then we can use this process. Magnetic impurities will get attracted and non-magnetic ore will be thrown out. So this way ore can be concentrated by using magnetic separation. So this method is used for separating, for concentrating ore of tin where impurity is iron oxide. Yes. Then this is flotation. Okay, so float means freeze. Whenever you put detergent powder in water and agitate it, move it, then you will see that the bubble, it forms a foam on the upper layer. That foam is also called froth. So, this process depends on the preferential wettability of the ore with oil. Generally, fine oil is used, and the gangue particles by water. So here one has to be hydrophobic and one has to be hydrophilic. Hydrophobic and hydrophilic. So generally impurities has to be hydrophilic. Hydrophilic means water loving. Water loving. So impurities has to be water loving, and ore has to be water fearing. Hydrophobic. And whatever is water fearing, that will be attracted towards oil. That means on what principle it works? Ore should get attracted towards oil, and impurities should get attracted towards water. Ore should get attracted towards oil, and impurities should get attracted towards water. So first of all, how do this method works? Powdered ore plus water plus finer. So crossed or grinded ore is mixed with water and fine oil. They are mixed thoroughly, and the slurry means mixture of all these is made. Then this slurry is added in ethyl xanthate. It acts as a collector to make the ore particles water repellent. So what is the function of this ethyl xanthate? It acts as a collector to make the ore particles water repellent. This ethyl xanthate helps the ore particles to go away from water, so that they repel the water, so that they do not get attracted towards water. So the function of ethyl xanthate is to make ore water repellent. Then this mixture, that means now the mixture part is powdered ore, water, fine oil and ethyl xanthate. And then the mixture is moved a lot, agitated with air. Air at very high pressure is passed through this mixture. Oil coated ore, being lighter, will form froth and rise to surface. When air at high pressure is passed, you can see here, compressed air is coming here, compressed air at high pressure. This is powdered ore plus water plus fine oil plus ethyl xanthate. Through this tube it is coming here, and then this air bubbles with oil weighted ore. So this here air is passed, and then this mixture, since that makes the ore water repellent, so ore moves away in the form of froth, in the form of froth. It moves away. This is froth. And impurities will settle down because they are water loving. Impurities are water loving, so they settles down. Gangue on impurities matrix settles down. But ore will go up in the form of bubbles. So formation of froth. So froth is formed. Impurities settle down. Then this froth is separated. So you can see here froth with sulfide oil. This froth is separated in different containers. So froth is separated, treated to get concentrated ore particles. Now from this froth, what is separated? Concentrated ore particles are separated very easily. So this is another way of concentrating ore. And generally this method is used for sulfide ores. I'm telling you, first one for concentration of ore was, what was it? Gravity separation. That method was generally done for iron ores and tin ores. Then second one was magnetic separation. That was generally done for non-magnetic ores. Where impurities are magnetic. Then this froth rotation is done for sulfide ores. Sulfide ores like zinc blende, ZnS and galena, lead sulfide are lighter than the impurities. So here impurities should be heavier than the ores. So present, they are concentrated by flotation process. So this way we use the process called for flotation. So in number 1, for using number 1 gravity separation, what goes to be heavier? What goes to be heavier? Ores has to be heavier and it has to be lighter. For using magnetic separation, ores has to be non-magnetic, impurities has to be magnetic. For using flotation, ore should be lighter than impurity so that they moves up. In the form of flow. Then the fourth process is chemical method or leaching. The fourth process of concentration of ore is chemical method or leaching. The ore is treated with a suitable reagent, acid, base or some other reagent. So in this process, in this method, what is done? The ore, crushed or grinded ore, is treated with a suitable reagent. This reagent can be acid, base or some other reagent, so that the ore is soluble in it. So here again, on what principle does it work? Ore must be soluble in the given reagent and impurity should be insoluble. One has to be soluble, one has to be insoluble. So what has to be soluble? Ore has to be soluble and impurities has to be insoluble. So then it can be easily separated. So but the impurities are now. The impurities are removed by filtration. Now what you do is you take a particular reagent and put the mixture. That will put this crushed or grinded ore and then start dissolving it. Ores will get soluble and then use the process called filtration. So through filtration, the soluble ore particles will get passed through the filter paper or muslin cloth, anything. Then the impurities are settled in the filter, filter paper in the form of residue, which can be filtered. Then through this filtrate contains some concentrate, this ore and the reagent, so this can be separated easily. Now the solution of the ore, that is the filtrate, is treated with a suitable reagent which precipitates the ore. Therefore, to extraction of aluminium, so generally for extracting aluminium we use this process called chemical method or leaching. So the leaching method is used for the concentration of metals like silver, gold and aluminium. So silver, gold and aluminium can be ores of this silver, gold and aluminium can be concentrated by using the process called chemical method or leaching. So on which principle does this chemical method or leaching works? Impurities has to be insoluble in the given reagent and ore has to be soluble in the given reagent. Okay. So which are the 4 ways of concentrating ore? Number 1 is gravity separation. Number 2 is magnetic separation. Number 3 is flotation. Number 4 is chemical method or leaching. These are all the ways for concentration of ore. That means by this we have finished second step of the extraction of metal.